In today's class, we are going to see about basics of machine learning. And this will be our basic topic of machine learning. And today's class, we are going to see very clearly what you mean by machine learning, how it is used in the industry, how it is being used in the prediction. Of course, when you know about this basics of machine learning, and you can able to get the other learning system, it means that regression modeling, multi-level regression, ANOVA table, and then all the neural network, all these things you can able to understand very clearly when you know about machine learning basics. The problem is that all the machine learning is doing the same prediction, but what is the difference between each and every algorithm? And that is going to be a highlighting point in today's class. And we are going to see how it has been used in industry or in a very small shop, how this machine learning is going to be useful for the other people in the society who needs the prediction is going to be seen very clearly through an example. And this is our main objective of this today's class. And now we are going to see something about machine learning. Now, when I talk about the machine learning, I'll just take a scenario like this. I think everybody knows about a Swiggy delivery system. Zomato, Swiggy. Okay, we'll just take about Zomato delivery system. Okay, delivery of food items. Now, this is going to be our example. Now, if a person is trying to give an order, for example, he'll be getting order. Order. It is your order number. Okay. When you talk about order number, is that I'll say that first order. The day one he starts with first order, or you can take any order per day. You would have been done 12 orders per day. Among that, you can take any 6 orders. I'll just take 2, 4, or I can even I can take that third. I'll just take it in a sequence way: third, fourth, fifth, and I'll make 5 orders. Okay. And when he does the orders, he'll be getting some tips. I just want to make it very clearly tips. For the first order of meal, it may be any item, I don't depend, but first order, okay, the person is getting a tips of 10 rupees. And when he goes for the second order, he gets the tips of 15 rupees. And when he go for the third order, he gets the tips of 20 rupees. And he gets the fourth order 10, and fifth order is 35. Now, this is the order and the tips which is being given to this particular person who deliver the food item to the home, and this is the amount. Now, what is this company people or your agent, who is delivering, will have an idea, will need a prediction that what will be my amount if at all is in the 6th order. Now, this prediction, this calculation, okay, needs the statistics, and we call this statistics as machine learning. Prediction-based learning is called machine learning. Of course, when you talk about the machine learning, what is the thing, how we can able to do this? Now, before going into this, I'm just going to plot this in a form of pictorial representation as a plot diagram. Now, if I give a plot for this, now I'll just make it like this. And I think I can make it in a bigger size. Okay, I'll just try to make it in a bigger size so that it will be convenient to understand. So I'm just going to make it. Bigger size one, because you have to see the table as well as you have to see the order number. That is what the reason I'm just adjusting my studio. Now, this will be my tip amount. This will be the tip amount. It's in rupees. And this is my order one. To make it 1, 2, 3, 4, 5, and 6. Okay. Now, I think I can make here as amount as 10, because maximum is 35. 10, 20, 30, 40, 50. This is my tips amount. Okay. Now, when I want to mark a point of 10, this is the 10, first order 10, and in this is your order. Because I'm very particular to show everything in parallel manner, the graphing and the values. Second order goes for 15 rupees. It is just here. And third order is 20. Third order is 20. Now it goes here. And of course, this point has to come here. Okay. Now, I'll just talk about this one later on. Third order. And fourth, I'll getting 10. And fifth, I'm getting 35. Here it comes around here. Okay. Now, this will be the plotting for tip order, tip and order. Okay. Now, when you talk about this, how do you evaluate this particular, what I can say, what will be by sixth order? The basic statistics which we can apply is that we can take mean value. See, when I take the mean value of this, okay, if you take the mean value of this, that will be the average of the sixth order. Now, because I have only one dependent, I have only one independent variable. It's not a dependent variable. It's an dependent. It is not a dependent variable. I have only one dependent variable. Okay, and it is a dependent variable because on order it is dependent variable. Okay, now if I want to make this to be averaged, I can make what is the average of this? It is 10 goes 1, 1, 2, 3, 5, 6, and then 7, 8, 9. I think it's coming around 90. Now, if I divide it by 5, okay, now if I divide by 90 by 5, I think 10, 25, 25, 45, and then you have 45, 90. Now, if I divide it by my average, what is the average? Now it becomes 90 divided by 5. Is that 1? 1. Then you have the 4. And you have your 4. It is around 8. Your average is that 18 rupees. So if I mark a line here, 18, I can make it this as a 18. Now this is the best fit of this line. Now this is the best fit. So this is what the line fitting. Say, of course, my diagram may be somewhat bigger or small, but try to understand, it is the best fit. Now, this is called outlinear data. It is that noise. Actually, you have 5 data, but you have the 6 data points. Something is called as an outlinear, or I can even say that it is a noise. Now, we are not bothered about this noise. Okay, now you got the idea. Now, this is the best fit line. This is the best fit line. Best fit line. Now, I think you can understand very clearly what is the best fit line. The best fit line says that it is an average of 18. Now, when these points are very close, for example, if you have third is about to be 20, very close to the 20, and whereas when you talk about fourth, it is about 4 is about what I can say 4 is about 10. Okay, and when you talk about 35, it is about here. Now, when I plot this diagram, when I plot the same diagram, now this is the point. Actually, the average is 90. Actually, this is the narrow, and actually this is the point. Okay, now this is your point, and now I think one already have this point. Okay, this point. Now, if I mark the differences, okay, if I mark the differences, 18 is your average value, and if it is a first delivery order, it is about when I minus it, you get your minus 18. Sorry, minus 8. The order is about minus 8. And then your third order is plus 2. It is above the value plus 2. Now when you go for your second order, it is about minus of 5. And when you talk about the fourth order, I think fourth order is minus 10. And when you talk about the fifth order, it is about 18. Sorry, fourth order. I think it will be. I think I made a mistake. Fourth order will be 8. About 8. One is 8 minus 8. Sorry, 8 minus 8. Okay. And your fifth order will be 18. So that how it comes. 35 minus of 18. Okay. What happens? 2, 20. Then you have your 30, 15. Okay. Now, if you subtract, I think you'll get 15. It is about 17. I think 18 plus 17 is that 3 goes 5. Okay. It is about 17. It is about plus 17. Plus 17. So now, when I calculate the error, now this is called as, you call this as error, or you call it as, or you can call as residual. Residual. Okay, it is called as residual. Okay, and it is called as residual. Now, you make sum of the squares. Sum of the squares. Sum of the square errors. Sum of the square error. Now, what actually it means that I'm going to make minus 18 the whole square. Okay. And then plus minus 5 the whole square. Then you will have your plus 2 the whole square. Okay, then plus 2 the whole square. And then minus 8 the whole square. Okay, now plus 17 the whole square. Now this is your error. See, when I plot this error, what is the purpose of going for sum of the squares? When you make the sum of the squares, what is the use of making the square is that it will remove the negative point and it will make only the positive value, first thing. And second is that the square makes this small value to look into a bigger value, a small value to be projected as the bigger value, and that is what the reason it is going to project as a bigger value. It's going to be as a bigger value. Now, if I draw this in a pictorial form, I think you can able to see how this is going to be a bigger value. Now I'll once again redraw this, and you can able to get it very clearly. See, I'll just redraw this diagram. Now this is called SSE. Wherever you go, you can see some of the errors where, or you can see this, you can even call as residual error. Actually, 18 is the average value. But the thing is that, if the best line fits all the data, what is by fitting all the data? It means that all the values, data points, should be very closer to the best fitting line. Now this becomes the less residual error. Actually, this is the correct. Actually, what this algorithm is trying to do, various algorithm, want to make this line, fitting line, very close to the data point. It means that error is very less. Your prediction is correct. And that is what you can see from this diagram. Okay. And now this is how you're going to make it. Now, if I draw this square, see, I made a square. If I make a square of these values, if I draw a diagram of the squares here, I think you can see clearly how the squares are going to be placed here, and you'll get a very good knowledge about it. Now, I'm just going to make these squares in the pictorial form. See, now what I'm going to do is that I'm just going to make a square. This is the 8. Now I'm going to make a square of 8 by 8. This is called 8 square. 8 by 8 means square. 8 square. Now, of course, it is called 64. Now, similarly, if I go for this 5, the square comes like this, 25. And this square is about 4. Now I think you can able to understand why this square is coming up. Okay. Now, once again, this square is about 64. Okay, 64. Now, I think you have your 17 square. 17 square. If you make 17 square, the size will be bigger. Okay, for 17. Now, if I mark this for this in terms of square here for these values, I can say like this as SSE is of 8 square, that is 64. And this is the pictorial representation of the squares. And then plus 25. And then you have your next square is that plus 4, very small square. Then when you make it as a very big square for your 64, that is your 64 square. And now plus 17 square. Okay, it is a very bigger than 64. 17 square, I think you can calculate it in the calculator, you'll have value. Okay, 17 square value will be there. And I think you can make it by using your calculator. Of course, this is not a very big thing to be included. It has some values. You make some value sets because now I don't have time to calculate this. Just you can put it. Now, this square size should be reduced. And that is what the real meaning for this SSE. Now, to reduce this size of these squares or residual errors, we go for different algorithm. Okay, you have your regression algorithm, ANOVA table, and SVM. All the machine learning algorithms, prediction algorithms will have the best fit line. Since my variable is only one dependent variable, only the tips amount. Okay, it is a dependent variable. And why I say it is a dependent variable, because the tips is normally based on the value of the purchase. So whereas the purchase is independent value, because these number tips are dependable. These tips are depending on the amount of bill. Okay. See, very simply, I can talk about it is that, if I buy for 10 rupees, I won't give a tips of 10 rupees. And that is what the reason we call it as this as a dependent variable. Try to be very clear. What is the purpose of saying it's a dependent variable? See, you should be very clear. It is a dependent. It is depending on what? It is depending upon the bill amount. Whereas here, bill amount is not dependable on the tips. And bill amount is individual. So it is called independent variable. It is called independent variable. It's called independent variable. And that's how you're going to understand from this what do you mean by dependent variable. Okay, and it is based upon dependent. Why it is called dependent? Why it is depending on based on the bill. Individually, a person will not give, if he buys for what I can say 5 rupees, and he will not give a tips of 20 rupees. So you understand what you mean dependent variable and independent variable is very important. Now you understand what you mean by residuals. Okay. Now I'm going to simulate this, and then I'm going to talk about one more in machine learning is that I'm going to teach you machine learning. Okay. I'm just going to take machine learning regression modeling. I'm just going to teach you regression modeling. And then I'm going to make something about a very different machine learning algorithm will be your neural network. Okay, now I'm going to give an explanation how this happens. Now you can able to understand what is my best fit of line. Any modeling will try to make all the data points should be very closer to these points should be very closer to the best fit of line, then the prediction is correct. This is how you make the understanding when you go for the prediction algorithm. I think now we have clearly given the explanation what is my basic fit, what is my SSE square errors, residuals. Okay, and we are going to see something about in real-time application by using the MATLAB. And when you talk about the MATLAB, I'll just give you one beautiful example by coding. Just I'll make it. I'll just share the screen. Please wait. I'll just go to the MATLAB. and you can able to get it very clearly. What do you mean by neural network? What do you mean by your how the neural network is performing in the prediction, and how your regression model is doing, and all the things you are going to see. Now, we are in meantime, I'll just before getting this MATLAB to be opened, I'll just want to give a small what I can say dependent variable. When you want, if you have only one variable, you have to go only with the mean value for the prediction. When you have both the values, okay, when you have the both the values, now I'll just make it the same values so that you can get it very clear. Please wait. I'll just go back to the studio. Now, if you have only one variable, you can go for only the average. Okay. And when you want to go for a prediction of the value based on regression modeling, it needs independent variable. It needs one more variable. It is not that it needs an independent variable or dependent variable, but still it needs one more variable in order to reduce these squares, the size of the squares. And this is the practical view of the mathematical explanation of SSE, or residual errors, or residuals. Okay, now, when you talk about this, I'm just going to go back to tip order. I'm just going to take the tip amount with the variables. Now I'll just go for what I can say. I'll just go for the tip amount, and that is your delivery order number. I'll just make like this order number. I'll just make this order number, and then I'll just make this order number 1, 2, 3, 4, and 5. And this tip amount is about, I'll just take the previous values 10, 15, 10, 15, 20, 10, and then 35. And then 35. This is the order number with tips amount. Now I am going to have my what I can say. It is a dependent variable. Independent variable is the bill amount. I'm just going to reduce the bill amount, reduce the error by having one more variable, which is an independent variable, because it never depends on order. It depends on tips, whereas tips depends upon the bill amount. Now, if my order is about 100 rupees, now it is about 150 and 200. Okay, and then I have my 150 once again. I have my 500 order. If the order amount is like this, now if I want to predict this, okay, if I want to predict this, what will be my sixth value? Now I'm just going to use my regression equation. Now this is what I'm going to program it in the MATLAB, and then I'm going to show you how the regression equation is going to be obtained. Now I'll just make it here, because parallelly you can view this also. Now I'll just share the screen. I'll just go to the MATLAB. I already have done some programs. I'll try to take those programs because it will avoid the typing problem. Now I never want to type once again. Please wait. Already I've done something with neural network programming. And of course, when you talk about neural network, what is the use of MATLAB is that more accuracy will be there in the MATLAB. You can do the same thing with Excel also, no doubt, but the value will be changing. But there won't be much of the changes in the value. There will be about a few, what I can say, very few percentage of error, very minor percentage of error will be there from what I can say, toolbox to toolbox. What do you mean toolbox to toolbox is that, when I do it in MATLAB, it will be in a different way. When I do it in what I can say SPSS, that will be in a different way. And that is what we are trying to say. There will be very minute changes will be there. Nothing else is going to happen there. Now I'm just going to make this neural network, and this is the neural network, and then I'm just working on this, what I can say, multi-level regression. These are the multi-level regression. Of course, these are the codes. Anyway, just for your purpose, just for you, I'm just going to take only what I can say one value. Then I'm going to teach you what is regression analysis. Now, I'll just take this value. I'll just take a simple code. Okay, now I'm just copying it and making as a small line code. Of course, here I'm not going to use this neural network, and of course I'm going to show the example with the regression, and then I'm just going to show with the neural network. And of course, this is the code which is for neural network. And of course, when I do this for when I do this regression equation, it becomes the what I can say. It is going to be the prediction equation. Okay. Now I'm just going to put the values, and what should be my y value? Y is the tip amount. When I say that y is my output, what is my output? Y is my output, and x is my what I can say billing amount. If my billing amount is of first bill amount, I'll just enter into the 100 is the first bill amount, and for first bill amount 100 rupees, I get 15 rupees as what I can say tips, and I'm just going to type everything so that you can also understand this. 150 rupees, and I make 15 rupees for 150. Is that the value? And for the third, is that 20 for 200 rupees, 20 for 200, 20 for 200, and 150 for 10, 150 for 10, 150 for 10, and 500 for 35. Now I'll make like this, 500 for 35. 35 is getting us a tips for 500. You should be very cautious when you type it. You have your 5 variables and top 5 variables. Now, if I plot this for regression equation, this is my regression equation. When I evaluate this particular point, what happens? You will get the plot. Please wait. It is showing the B.Sc here. And of course, the accuracy is about 0.9. It means that the R square value, okay, R square value is about, okay, the R square value is about, once again, R square value, I think you can see here, R square is about 0.96. It means that it is a positive trend. The accuracy level is about 96%. Now, when no error is there, about only what I can say 96.4% of error, something like that. Now, from this, how to make your equation? How to make your equation, regression equation modeling? Now, I'll just switch on to my board so that you can able to see. You can see here B value is 50, M is 15, and your what I can say. Your R is about 9.6. R is that SSE values, root mean square values. That we'll talk about later on. But of course, a very big clue I want to give you that if the R value is about to near or 0.6 to 0.7, it is more accurate about your data points. Accurate, it means that they are highly correlated. If the range is between, of course, from 6 to 7 or 7 to 1, it is an highly correlated. The variables and independent variables are dependent on independent variables highly correlated, and that is what it is being explained here. Now I'll just go to my studio so that I can explain. I think you can understand -50 and your 15 value. Okay, and that is your real value. Now I'll just stop this. Now already you have seen from this equation is that that the best fitting of line is that y is equal to mx plus c. Y is equal to mx plus c. Okay. Now, y is your as I given is that your tip amount, and x is your order or bill amount. It's about the bill amount. It is your bill amount, and c is your constant. C is your constant. C is your constant. Now, I'm just going to have from my previous MATLAB. I'm just going to show you that is that the MATLAB has shown you that I'll just share it and you can able to see this. Now the MATLAB has given your M value, M value and B value as 15. Okay, B value is 15. This is how you have your M value and 15. Okay, now I can even change this value. Yeah, and one more thing I want to show you is that, now if I want to have the regression in this fashion, instead of X and Y, I never have any change here. And that is a very important thing. When your variables are changed, also nothing is going to happen here. Now you can see this evaluation. Okay. Now, when you change this parameter, you will get this valuation. I think now you can see the diagram. Okay, you can see this diagram very clearly. Now, y is equal to mx plus c. Now, y is equal to mx plus c is that I have my nothing is going to change. Okay, when I make x dependent y both will give the correct answer. Okay, now when you have this y is equal, now I'll go for the studio. Now I'll just note down from my coding is that b is equal to 4.22 and m is equal to 0.0626. Okay, and above, of course, your r value is, because it doesn't have any change, because r is equal to 0.96 previously and now also. Now you can see from this diagram, a very important thing is that the equation is given in this diagram is that output, I'll just write down these things in my paper. Output is equal to 0.63, okay, into the target. Okay, the target plus 4.2. Now, if I show the studio, you can able to see these values. Now, this is what your graphical value from the plot. Okay, and this is the value from your what I can say coding. Now, if I put the value for my sixth prediction, is that here output is the tips. Once again, you can see that this is the bill amount. Target is your bill amount. You have to know based upon the language, these things are variable. Sometimes if you go for some other tool, they'll give alpha, beta and all. Of course, I'm just using my MATLAB. So I'll put it from my calculation. From the coding, I get y is equal to mx plus c. So the equation is that m is 0.0626 into x plus c. That c value is 4. Here c is represented as b value. It is 4.22. It is 4.22. Okay, it is 4.22. Now, if the bill amount, in order to reduce, if the bill amount is about 250, assume that if the bill amount is 250, what will be my tip amount? Now, for this, I'll use this equation. So what I'll do is that I'll just make 0.0626 into 250, okay, plus 4.22. Now I'll just show this in the coding. Now this is the thing which I have taken from the equation, is that I have taken from the values which I obtained, which I have taken from the workspace. It means that when I write a code in left hand side, I was able to see this m value. And I think if you are not able to get it, I'll just share once again where these values I have taken. Now I can able to show you here, this is the value. I think you can able to see here, I'll mark it here. You can able to see this is the value which I have taken from this code, b value, and m value. M is the slope and b is the constant. Of course, this is the constant and this is the slope of the straight line. And the other one which I said that I have taken from the plot is this value. Okay, now this is the value I have written in the textbook, notebook. What I've done, this is from the workspace which I marked, and this is from the plot. This equation is from the plot. Now I'm just going to put this in the calculations. I'll just, whenever I want to use the calculator, I'll just make here itself so that you can get it very clearly in the plot itself. Now I'm just going to make it as prediction. Now this prediction is going to be done. It is called, I'll just make here, it will be very convenient, you can understand. It is called prediction. Now I'm going to take prediction. My first prediction is from the calculated value. I can make it like this from calculated value. Now the other one is that one more is that is that your plot value. It means that from the diagram you have taken this some values. This is the plot value. Now I'll just include this. I'll just make like this. My first equation for the value is y is equal to y, or I can make it tips. Tips is equal to, okay, 0.0626 into the tip amount is that what I'm going to make it is 250 plus 4.22. Okay, 4.22. And now when I go for this equation which I got from the plot, what is that? Is that your out? What is again? I'll make it as per the plot. It is output. Output here means is tips. Same thing. Nothing is beyond this. I'll make it the bracket so that you can understand. Tip is equivalent to, okay, and the value which you got is 0.63, okay, into 250 into 250 plus 4.2. Of course, I have reduced it. Okay, 4.2. Now I run this equation so that I may get the value. What will my tip value? Now, my tip is about the 66th. What I can say, I think you can able to see in the screen the sixth. I think you can able to see here sixth order. You will get 19 rupees. And as per the plot value, it means that the plot regression value, what it is says that it should be. Once again, I'll just make it as a bracket. I left the bracket as a first. If you make like this, it's not trying to take this. Please wait. I'll make it as underscore just for the understanding purpose. I made it underscore. Now you'll get it. And now the tip value is 19.950. Nothing is going to make a very big difference. That is what I said. From the first equation, you get, I think you can able to see here, because this is the equation which you got from the calculated value, and below, output of your plot value is that, very not a very big change. You can see this value as 19.98. This is the tip value from the plot. What do you mean by plot? This value, this equation. I didn't take entire value. I just made like this. Okay. And this is how you can use this value, target value. Now, you can see this regression equation. No doubt what the regression says that X value is kept as such as X value, and Y value is kept as Y value. Nothing is going to change. Okay, when you use your linear regression modeling, when you use your ANOVA, when you use your SVM, any sort of equation. But when you go for neural network, what happens? And that is a very beautiful thing, is that it will take this value, 50% of training and validation, and it is going to use this for testing. Then it will tune the data. I think what you mean by tuning of data, that's that I'll I'll show you by applying in the code. Then you will be able to understand very clearly. That is the easiest way to make understanding of this neural network. What neural network is doing, you can see it practically. That is very important here. I am expecting from you all, you can able to understand very clearly, is that X, Y. Now I'll make the plot as X, Y. Okay, X, Y. Okay. Now I'm just going to clear this. I'm just going to clear this, and I'm just going to run this code. Is that it is called neural network. You can see this net. Net is the default neural network, and train BR is the training function used for the network. Now I'll just run this code. You can see this. Wait, it takes some time. You can see the plot. I think you can see the plot. The plot says that previously it was 0.62626 X into 4.22 when I go for the value here. When I go for neural network, the accuracy is increased from 0.96 to 99. This is a very beautiful example which you cannot able to get it even by reading many textbooks. You will not understand what is in my machine learning. And many people, they think that, you can see very beautiful results which you have obtained here. And you can see this, the R square value, it is meant R value is increased. It means that accuracy is increased. How this has been happened? The values are same only by using neural network. What the neural network is really trying to do is that, a very important thing is that if I go here, you can see this Y value would have been tuned because it would have been trained and it have been assumed that the fitting line has to be matched so that you get an exact value. And this is a very simple example. You can get it from the neural network. What actually in your previous thing was happening, it never changed your X and Y value, whereas your output value is being tuned. This is what they call it as neural network based tuning the algorithm. Now you understand the normal regression algorithm, which is giving a predictable answer, an equation y is equal to mx plus c, whereas this equation has given very clearly is that tuning the y variable, making the y variable to adjust itself so that maximum of the data points are fixing to the best fit of the line. I think you can see this previous diagram and this diagram very clearly, and you can see this very clearly. And you see all the data are in the on the fit line. It's an exact, accurate value. This is what the real meaning of the neural network. Neural network does this by based on tuning your input value. How that has been done? It has been done by using your training, and then it has been used by your, what I can say, I think you can able to see this performance curve, training functions, okay, and validation, testing, and all those things. You can see the report now. So this is called training, testing, and you have zero error. Okay, you don't have zero error. I think now you understand what you may target minus your output and how many instant it has been happening. Now, how many times it has been tried and it has been got into the pins. It means that it has done many trials and error in loops. Then this is how the regression goes here. The regression plot shows very clearly. You have your value as 9.9625. Okay, and the value has been changed here as 9.96. This is for training and this is for testing. And of course, this is for your final target, all the value, training and testing. What do you mean by training and testing? What do you mean by neural network? What do you mean by deep learning? Of course, I have to teach all those things in my next class, how to get this. What do you mean by training? What do you mean by what I can say testing? What do you mean by what I can say hidden layer? What do you mean by layers and all those things? Of course, in my previous class, I have taught about the layers. Unless otherwise you doesn't know what you mean by layer, you cannot get into the concept of a neural network, and you cannot understand. You have your layers, 2 layers, whereas in neural network you will have 128 layers. So accuracy is far better than machine learning, and more far better than neural network. And of course, in my next class, I'll be trying to explain about neural network. Don't worry, we'll try to give a very clear-cut example right now how we have explained all those things. I think you understand very clearly practically. Now, if I want to take this equation, if I want to plot this value for the accuracy, is that I'll make this equation. How I did it for prediction, same sixth value. I'll make it 0.59. 0.059 into 250, okay, and plus 5.3. Now I'll just make this equation here, and this is the prediction equation, and I'll take this same equation, because to show you here, I'll make it here. Now the new equation after neural network has been changed into 0.59, okay, and the value of constant has become 5.3. Now, if I run this particular line for the what I can say your prediction of tip value of the 6th order, now it is 20.0500, and this is the right accurate answer. And this is a very important thing. And one more thing I want to say here is that the neural network is mimicking of the brain. Brain never thinks in the same pattern. It keep on changing. So in that way, if you make this your neural network, and whenever you run your regression modeling, you'll get the same answer, no doubt. Whereas when you run your neural network, because brain never thinks in the same way, 100 times you think in a different way. Your decisions will be keep on changing. Same thing you can see in this program. Now, You got this equation. Now I'll run the same code. I'll clear here. And this is the one more example I want to teach you practically what in my neural network and how the decisions are being changed. Now I run up to the progression. That is your plot of regression. Okay. Now if I run this, once again, my RL will be changing. I think you can see this R value. Please wait. Regression value is that. See, now it has been changed. 0.7, target 5.5. Every time you keep on running, it will keep on changing. Every time. Now, previously it was, I think you can able to see, yes, previous equation was about 0.57, 59. Now it has become 0.77 and target of 5.8. Now you won't get the repeated value. This is how your brain thinks. Now, if I run the same code, and this is a very beautiful thing of the neural network, which is not been taught in any YouTube or which is not been taught in any textbook, because they think that the teacher who handles the neural network, they think that people are strong enough in analyzing the statistical. They never correlate with the practical calculation with the simulated coding. It means that now what I did it as a calculation. I did it as a neural network where it is changed. This is what really missing in the neural network teaching. Of course, you are so lucky to listen this, and of course, after listening this, you can have all the algorithms understanding very clearly. Now I'll make this regression value. You can see this now. Once again, the value has been changed. It is now 0.7. 0.7279. Now you will be having a very big question, sir, whether the values are keep on changing. Yes, very good. Values will be changing because your neural network is mimicking of your brain. It replicates the human brain. Human brain never thinks on the single pattern. Only robot will think in the single pattern. Okay. Whenever human thinks, every time your decisions are keeping changing for every day, every minute, every time, even for the repeatable job. And that is what reflected here, because you have training and testing. Of course, this will be teaching in the next class, what you mean testing, training and validation and all those things. Now you understand the concept, how it is being related by the values and how your neural network is trying to change it. I think you can understand. If you have any doubts, you can put your questions in the chat box. And if you have any questions, you can even ask through my WhatsApp number, 944200 I think we'll see in the next class. Thank you very much for listening to this lecture. And I expect your feedbacks in the chat box. Thank you very much. I'll stop the recording.